Hi guys, welcome to my tutorial. My name is Samuel Tochku Brainy, and in this video we are going to be doing special types of linear programming problems. This is one of the topics that mathematics undergraduates do in the university. I think in a course called Operations Research. And one thing I love about this topic is because it's very interesting and it's very easy to learn because it deals with things that we just see around us almost every day. So without wasting our time, we'll go into the special types of linear programming problems. In the special types of linear programming problem, we have the transportation problem, we have the assignment problem, we have graph and networks, maximum flow, shortest distance, and critical path. So we are going to start with transportation problem. What is a transportation problem, or how do we identify a transportation problem? I'm going to explain this using an example. Let's say a company that produces maybe drinks, and they have four places where they produce the drinks. They have the port A, port B, port C, port D, where they produce these drinks, and then they have a store where they take it to so that people can buy it from the store. So let's say the stores they have the first store, the second store, and the third store. They have three stores and they have four places where they produce these drinks. And then the problem arises when they try to find the least amount that they will be spending to transport these drinks from these places that they are produced to the different stores. Let's assume that the various production units A, B, C, and D, that they have the maximum amount of production that they make in a day. So let's say the unit A, they make up to 150, they produce up to 150 goods in a day. B produces up to 300 goods in a day, and C produces up to 200, and as well D. And then these stores, these three stores that they have in various places, they have a maximum amount of goods that they can contain. So the capacity of the first store, which is the store one, they have a capacity of 200 goods, and then the store 2 has a capacity of 300 goods, and the third store have a capacity of 250 goods. So we wrote supply here and demand here, showing that this place, this store has 150 goods. I mean, this production unit has 150 goods to supply to any of these units, and as well we can take 300 goods to supply to any of these units. So how do we supply these goods to these various stores and spend the least amount that we can spend in transportation? And then the figures we see inside here are the cost matrix. That is the amount it will cost us to transport a good. Let's say we are talking about this, it means the amount that we will be transporting one good from this unit A to the first store. So it will cost us $4 or 4 naira to transport a product from unit A to the first store, and it will cost us $7 to transport one product from unit A to the second store, and $9 to transport from this place to this place. The first thing that we'll do before solving a transportation problem is to check the supply, the total supply, and the total demand. And we check if the two of them are equal before we start solving. If they are not equal, then we'll make some adjustments. But if they are equal, we just continue to solve it. So we check the total supply here is 150 plus 200 plus 200 plus 250, and that should be 800. We have 800 goods to supply from there. And we check the total demand. We have 200, 350, 250, and this is a 600 plus 200, which is also 800. So we find out that the supply and the demand are equal. So we start solving the transportation problem. So there are three basic ways to solve the transportation problem. There's the northwest corner method. I'm just going to write the abbreviation. Then when we start solving, I'll write it in full. So have the northwest corner method, NWCM, and then we have the least cost method, LCM, and then the Virgil's approximation method, which is VAM. We are going to be using these three methods to solve this problem. I will see the differences between the three of them. The first that we're going to be using is the northwest corner method. So how does the northwest corner method work? Just in your graph, you have something like this, or in the cardinal point you have the north here, we have east here, this is south, and this is west. So northwest will be along this line. So this is northwest corner, the northwest. So this line is pointing to northwest. So if we bring this graph and place it somewhere here in the middle of our board, so we'll have something like this and like this. So our point, this line will be going this way. So what northwest corner method is trying to say is that the first place that we should start our solving the problem is that we should start from the very first cost, the very first place. We start from here, we go from this place, we satisfy this first, and then before we go to the next one, we just continue to use this graph to go like that. So we are going to start with the northwest corner method. I'm going to write it in this place. Solving this problem using the northwest corner method, the first place that we are going to satisfy is this. So in this place, transporting from unit A to the first store, we are going to spend $4 for each goods that we are going to be transporting. So we have in the unit A, they have 150 goods to supply, but the first store has the capacity of 200 goods. So what do we do in this case? In this case, we are going to supply the 150 goods that we have in store A, and then we go to the next route to the store, the first store, and then supply the remaining that they want. So we are going to supply 150 goods to this place. We have 150 goods, and after supplying the 150 goods to them, and the unit A will have, if we supply 150 goods to them, we'll have no other goods remaining. So here will be 0, and then we have already taken out everything that's in unit A. So we just rule it out, and then we check for the first store. We've supplied, they need 200 goods, but we have already supplied for them 150. So what will be remaining here is 50 goods. So they are still demanding for 50 goods. So the next thing that we do is to still bring our graph, we plot it here, and then check for the for the northwest, and northwest is 10. We'll be transporting from B to the first store. So transporting from B to the first store will cost us $10. In B, in unit B, they have 200 goods to supply, but the first store needs only 50 goods. So we are going to supply them 50 goods and then leave the remaining here. So we'll have 50 here. We supply them 50, and then what will be remaining in unit B will be 150 goods. 150 goods. So we have already supplied the first store. We supplied them 150 at the first time, and we'll supply them 250, which will complete the demand that they need. So they don't need any other good here. So we roll this out, So the only place that remaining here is now this. So what are we going to do? We are going to plot our graph again in the middle of the board, and then we find out that the next place will be transporting from unit B to the second store. And right here in unit B, they have 150 goods remaining, and second store they need up to 350 goods here. So we are going to supply them with the 150 goods that we have in unit B. So we have 150 here, and then uh, unit B have already exhausted what they have, which is 200. So we rule that out, and after supplying 150 to the second store, they will still have 200 goods that they are demanding. So we go to the next number, which is this, and we'll try to see if we can supply them their the number of goods that they want. So uh, they are still demanding for 200 goods, and in unit C we have 200 goods, so we'll supply them the 200 goods, and then we'll find out that everything in unit C have been exhausted. We have 0 here, and then we have already satisfied the demand here. So the next option that we have is just this, and here the third store they need 250 goods, and indeed we have 250 goods, so we supply them the 250 goods that they need, and then that's the end of using the northwest corner method. So we are going to calculate how much we are going to be spending to transport all these goods, to supply all these goods from the units to the various stores. So how do we calculate this? We say that the total transportation cost, the total transportation cost using the northwest corner method will be equal to, let me start from here. So equal to, we have for each good that we transport from A to 1, we are spending $4. So multiplying this with 150 goods will give us 4 times 150 plus, we transported 50 goods in B and we spent $10 for each good. So 10 times 50 plus, in this place we have 15 times 150 plus 8 times 200 plus 8 times 250. The total transportation cost transporting all these goods using the northwest corner method will give us $6,950. So I'm going to write the solution that we got up here. We have 6,950, that is using the northwest corner method. So we're going to solve the same problem using the least cost method, so that we will know the difference between the northwest corner method, the least cost, and the Virgil approximation method. So I'm going to just wipe off the board, rewrite the questions, and then solve it using the least cost method. How do we solve the same problem using the least cost method? In the least cost method, we have all the costs here. These are the costs that we have in each of this place, how much it costs us to go from each unit to the different stores. So, and the least cost method says check all the stores and pick the smallest of all the costs and then supply to that place first. So supply using this route from we go from the unit B to the third store first, and then we supply to them before we go to any other store. So we have in the unit B, they have 200 goods to supply, but the third store, they are demanding for 250 goods. So we supply them the 200 goods that we have in unit B. We have 200 here, and then after supplying, we check how many goods do we have remaining in unit B. We have 0 goods remaining here, so we remove this unit B out of our table. And then in the third store, how many goods are they demanding still? So we have 50 remaining here. So we have already taken out all the goods in B, that's why we removed the column. And then we check for the remaining costs that we'll have there. We'll have this, we have this, and this. So we check for the smallest again and supply to them. So out of all these costs that are remaining, 4 is the smallest cost. So we supply to this place. We are traveling from unit A to the first store, and we're going to supply to this place. So unit A, they have 150 goods here, and the first store, they are demanding for 200 goods. So what do? We supply the 150 goods that we have in unit A, and then we check how many goods we have remaining here. 0. So remove this column. And then how many goods do we have remaining here? We have 50 still needed in this store. So we just have these 2 columns remaining, and we check for the smallest cost among them. The smallest cost here is 5. So we are going to take from unit D to the first store, and we are going to supply. How many do we have in unit D? We have 250, and in the first store, they are still demanding for 50 goods. So we just supply them with 50 goods. And then what is remaining in unit D? We have 200 here. And then the first store is already satisfied, so we remove that row from our table. So what do we have remaining? We just have going from C to the second store and third store, and the same thing here. So have 8, 9, 8, 9. So what is the list? The list is 8, but we have 2 calls that are 8. So we just pick one and then supply to that one first. So let's pick this. We have going from unit C to the second store, and in the second store, they are demanding for 350 goods, and unit C has only 200 goods, so supply them 200. And then how many goods are remaining in unit C? 0. And then here we still have 150 goods remaining here, so we take out unit C, and all we have left is just this column. Now what is the least between this and this? 8. And we supply to this place. We have 50 here, and we have 200 here, so we'll give them 50, and so that we will have 150 remaining here, and then we have 0 remaining here. So we take out this row, and then we go to the last root, which is 9. We have 150 here, and we have 150 here, so we supply them 150 goods, and then every other. So we have ended up supplying all the goods that we have to each shop. So how do we calculate the total cost? We calculate it using the same way we did in the Northwest Corner method. So I'm going to write out the total cost. We have the total cost, total transportation cost. The total transportation cost using the least cost method is 4 times 150 plus 1 times 200 plus 8 times 200 plus 5 times 50 plus 9 times 150 plus 8 times 50, and that will give us $4,400. So we from the Northwest Corner method that we used before and this one, we find out that this is better in this solution, in this problem, using least cost method is better in this problem because we are going to spend less amount if we use the least cost method. So I'm going to write it up here. I'm going to write the result I've got up here, and then before we use the Virgil approximation method. So I have 4,400. We are going to solve the same problem using the Virgil approximation method. We still have the same problem here. The only difference is just the differences that we wrote here, and we just have the same problem. And so the Virgil's approximation method is a little advanced, and this man says that when trying to solve a transportation problem like this, you just go through each of the rows and check for the two smallest costs in each row, and then subtract them, write out the difference. So the first row, the smallest cost here is 4 followed by 5. So we subtract the two of them, we have 4 and 5. So we have 5 minus 4, and that will give us 1. So that's the first difference for the difference for the row, first row. And so we in the second row we do the same thing. So we check for the two smallest costs in the second row. So the two smallest costs in the second row is 7 and 8, and then we subtract them. I will have 1. So we check for the third row as well. In the third row we have 1 and 8. So 8 minus 1 will give us 7. And then we do this same thing in each column. We check for the two smallest costs in each column and subtract them as well. So the two smallest costs in this column is 4 and 7. And so we subtract them to have 3 here. So we have 10 and 1. We subtract and we have 9 here. And here we have 8 and 6. 8 minus 6 will give us 2. And we have 8 and 5, which is 3. So after getting the differences, the Virgil approximation method says go through all the differences, both the ones that you got through the columns and the one that you got through the rows, and then check for the biggest number there. So we have 3923 here. I'll have 117 here. So what is the biggest number that I'll have here? The biggest figure here is 9 under a column, and then we check what's the smallest cost in this column. The smallest cost among all these is 1. So we supply to that place first. We supply through that route first. So we have unit B, and we are supplying to the third store here. So in unit B we have 200 goods, and in the third store they are demanding for 250 goods. So what do we do? Supply 200 goods to this place through this route, and then the unit B, what will be remaining here will be 0 goods, and then we have 50 still demanded in the third shop, in the third store. And then we, after supplying this, we take out the unit B because we have already supplied everything that we have here. So we after doing this, we check out for the differences again. So in this column we still have 3 here. We go through the, and then for this column there is nothing here again because we have already supplied everything here. So put a dash here, and then you go through this place again, we have 2, and then in this place we still have 3. Now we check the rows again. We are not going to be using this. We make another difference because this column has been removed. So we have the smallest cost here is 4 and 5. So subtract them, we have 1. The same thing here, we have 1, and then the smallest cost here is 8 and 9. So we have 1 here. So right now we check through our differences again, the last one that we did, and we check what is the biggest number here. The biggest number here is 3. So we have 3 here and we have 3 here. So what do we do in this case? We just pick any one of them. So let's pick this. We have 3 here, so pick 3, and then we go through this column. We check what's the smallest cost here. The smallest cost here is 4 in this column, and in this column this is unit A and store 1. So we have 200 here. I'll have 150 here, so we'll supply 150 goods to this place, and then we subtract it from here. We'll have 0. Take out 150 from here, we'll have 50. So we have taken out everything that is in unit A. So rule this out, and then we still have this only C and D remaining. So we calculate our differences again. So the third difference will be this minus this, which is 1, because there are only 2 costs remaining in this row again. So I have 1 here, this minus this is 1, and then we do the same thing for the columns. So coming to this place, we have already taken out everything that is here, so we don't have to subtract anything here. So I have dash here, the same thing here, and then right here we have 6 minus 8, which is 2. That's the 2 smallest costs, and then right here we have 8 minus 5, which is 3. So in the third differences, we have 3 as the biggest. So we pick this place, we pick 3, and then we check in this column what's the smallest cost here. It is 5. So we have 5 here, and right here we have 50 goods. We have 50 goods here, and the supply units, we have 250. So we supply 50 to them. To supply 50 here will be 0, and what will be remaining here is 200. So this place is satisfied, so we'll take out the first row. Now we have just this remaining, and then we still do go through our differences again. So right here we have nothing, we do our differences again. Then in this place we have just 8 and 9, so we'll subtract them and we'll have 1, and then we subtract this and we'll have 1, and then we do the same thing in the rows. So in this row there's nothing here left, so we put a dash here, and then here we have 9 minus 8, we have 1, and same thing here, 1. So we have 1 all through these places. So what do? We just pick any one that we choose to pick. So let's take from this place, let's take from the row. So if you pick this difference, what's the smallest here? The smallest cost here is 8. So we supply to this place. Now in this 8 is combining C and S dot 2. So have in unit C we have 200 goods, and this place is demanding for 350. So we supply 200 to them, and then we have 150 remaining here. So C have already been satisfied, and then we have just this and this remaining. So right here, the smallest here, we subtract, we do the same differences again. So right here we have dash, a dash, here the same thing. Now here we have 9 minus 8, which is 1, and then in this place we do the same thing for the rows. This place have already been taken out, so we have this. Now right here we have 9, and then for this row we have only 8 remaining. So among the differences, 9 is the biggest, so we pick 9 here, and then we go through this row. We have only 9 remaining here, so we just pick this place and supply to it. So we just have 150 here. I'll have 200 remaining here. So what do? We supply 150 goods to this place, and then we'll have 0 remaining here. I'll have 50 remaining at this place. So we just take out this place because there's nothing left here, and then we just have only this, and right here we'll have 50 goods. I'll have 50 goods remaining here, so we'll supply the 50, and then the next thing that we'll do is we calculate our total transportation costs. So I'm going to just wipe out this place to make so that we can be able to calculate this and then see the result. And so we have that the total cost using the Virgil's approximation method will give us $4,400, and this the same result that we got using the LCM, that's the least cost method. This is not always the case. Getting the same results with using approximation method and the least cost method is just for this problem. So we'll be doing one more example.